Hello students, we'll continue now with the next topic. The distribution of the values of a statistic for different samples of same size is called its sampling distribution. Now, if here there is a parameter, maybe this is where we are taking one population, and here we take some random sample of size n. So this will be a sample, and anything constant with this will be a statistic, and anything like a mean or a standard deviation with regard to the population will be a parameter. We take another random sample of same size, and then the distribution among these statistic will be a sampling distribution. So the distribution of values of a statistic for different samples of same size is called its sampling distribution. Now we'll take here, there are three different balls of size 1, 2 and 3. So the population, the mean of the population, this will be a parameter nu. That will be 1 plus 2 plus 3 divided by 3, which is nothing but 2. Now we take two random samples of same size. We'll choose some two random balls. Maybe it can be the ball 1 and ball 2, and we'll find the sample mean, that is x bar. So 2 plus 1, that is 3 divided by 2, that will be 1.5. Same way we'll take another sample of same size. We are going to take two balls. It can be any two balls, some random sample we are taking. So we'll choose the ball 1 and ball 3. So 3 plus 1 is 4, 4 divided by 2 is 2. So the sample mean of this sample will be 2. Similarly, we can make a table of the different options. We can take ball 1 and ball 1. We can take ball 1 and 2. We can have a different distribution of the sample that we are taking. It can be this sample, or we may choose 1 and 2, we may choose 1 and 3, we may choose 2 and 1. So these are the different chances of picking the balls. And then we'll find the sample mean of each of the picks. Like when we pick the ball 1 and 1, what will be the sample mean? When we pick the ball 1 and 2, what will be the sample mean? And we'll make a table. And then we'll draw a graph. So what will be the graph of this each sample mean? So this will be the sample distribution for the sample mean for sample size n equals 2. So this is the sampling distribution. The standard deviation of the sampling distribution of a statistic is called its standard error. So the standard deviation of the sampling distribution of a statistic will be called its standard error. Now we'll see what is standard error of means. Let a random sample of size n be drawn from a population with mean nu and standard deviation sigma. Then the sampling distribution of the sample mean x bar has mean nu and standard error as sigma divided by root n. So we'll take a random sample of size n to be drawn from a population. We'll take this one population. This has mean as nu and standard deviation as sigma, this population. From this we'll take a random sample of size n. This will be a random sample of size n. So let a random sample of size n be drawn from a population with mean nu and standard deviation sigma. Then the sampling distribution of the sample mean x bar has mean nu. So this sampling distribution will have a mean nu and standard error of this mean will be sigma divided by root n. So let a random sample of size n1 be drawn from a population with mean nu1 and standard deviation sigma 1. So I am taking one population. This is the population whose mean is nu1 and standard deviation is sigma 1. I am taking a random sample of size n1. Similarly, a random sample of size n2 be drawn from another population with mean nu2 and standard deviation sigma 2. So I am taking another population, we'll take this as P1, we'll take this as P2, whose mean is nu2 and standard deviation is sigma 2. We are taking another random sample of size n2. Let x1 bar be the mean of sample drawn from the first population. Let x1 bar be the mean of the sample drawn. This will be the mean of the sample. And x2 bar be the mean of the sample drawn from the second population. So this is the second population. So x1 bar, x2 bar is the mean of the sample drawn from the second population. Then the mean and standard error of difference of sample means. Now we'll find the mean and standard error of difference of sample means. We are taking the standard error and mean of the difference of the sample mean. That will be E will be x1 bar minus x2 bar will be the difference between this mean and this mean, u1 minus u2. And standard error of the difference of the means will be nothing but root under sigma 1 square divided by n1 plus sigma 2 square divided by n2. These all formulas will be required in calculations. So we got the standard error of means. Next we'll see the standard error of proportions. This is also same as the standard error of means. Let a random sample of size n be drawn from a population with proportion p. Here we were taking the same one random sample of size n from a population with mean nu and standard deviation sigma. Here we are taking a random sample of size n to be drawn from a population with proportion p, because this is the standard error of proportions. Then the sample proportion p, the sample proportion whatever we are taking the sample one, has mean p and standard error will be root pq divided by n. So the sample proportion p has mean p and standard error as root under pq by n, where q will be nothing but 1 minus p. Let a random sample of size n1 be drawn from a population with proportion p1. Similarly, a random sample of size n2 be drawn from another population with proportions p2. Let p1 be the proportion of the random sample, be the proportion of sample drawn from the first population, and p2 be the proportion of sample drawn from the second population. Then the difference of sample proportion p1 minus p2, the difference. Now again we are calculating the difference of sample proportions. We are taking two populations with proportions p1 and p2. From that we are taking two random samples of size n1 and n2. Now we are finding the difference of the sample proportions p1 and p2. Mean will be E of p1 minus p2 will be capital P1 minus p2, and standard error of the difference of sample proportion p1 minus p2 will be root under p1 q1 divided by n1 plus p2 q2 divided by n2, where q1 will be 1 minus p1 and q2 will be 1 minus p2. If p1 and p2 are same, if the two populations which we are calculating has same proportions, both the population has same proportion, that is p1 equals p2, which is p, then the standard error of the sample proportions will be difference of sample proportion p1 minus p2 will be root under pq into 1 by n1 plus 1 by n2. Here we have a table. We have calculated this. You have to remember all these formulas. Thus mean and standard error of some statistic. These are the statistics. These are the mean of these, and these are the standard error. We have calculated all this here. So this is the derivations of all the different formulas. In the next class, we'll see some examples on this. Thank you.